So we're doing MYP3 Unit 2 and Chapter 2 is indices. So indices or index numbers or powers, or you often see the word exponents as well, are the little numbers in, I've written expressions, maybe terms I should say, terms like 5 to the power of 3. So 5 to the power of 3 means 5 times 5 times 5. It's 5 multiplied by itself 3 times, which isn't the same as 5 times 3, which would be 15, but it's 5 times 5 times 5, which is 125. And people often make the mistake there of thinking 5 to the power of 3 means 5 multiplied by 3. It doesn't. Danish word there, potenser, for powers. So be aware of that if you're whether you're Danish or not, you should be aware of the Danish words when you're learning maths in Denmark. So the rules of powers. So for example, 17 squared, or 17 to the power of 2, times 17 cubed, or 17 to the power of 3. So that means 17 times 17, which I've put in brackets, times 17 times 17 times 17, which I've put in brackets. Now those brackets don't really need to be there, so you could just read that as 17 times 17 times 17 times 17 times 17, which is 17 to the power of 5. 17 multiplied by itself 5 times. Now you'll notice that 5 is 2 plus 3, and it's 2 plus 3 because we had two 17s there multiplied together, and we multiplied them with 3 17s there multiplied together. So we got the 5 from 2 plus 3. So that gives us a general rule. In words, when you multiply powers of the same thing, you add the powers. In symbols, x to the power of a times x to the power of b equals x to the power of a plus b. So when you've got the same thing raised to two different powers, and you're multiplying those together, the rule is add the powers. Here's another example giving us another rule. So this time 17 to the power of 6 divided by 17 to the power of 2, or 17 squared. So I've written that out as a big fraction with 17 times 17 times 17 times 17 times 17 times 17 on the top for 17 to the power of 6. And 17 times 17 on the bottom for 17 to the power of 2. So a fraction is like a division. The line in a fraction means divide. So that's just another way of representing the same thing. Now, writing it that way, you can see that two 17s on the top cancel with two 17s on the bottom. So that's what those green lines are. That's cancelling out. And that's leaving me with 17 times 17 times 17 times 17 on the top. So in other words, the whole thing's equal to 17 times 17 times 17 times 17, which is 17 to the power of 4. 17 multiplied by itself 4 times. So 17 to the power of 6 divided by 17 to the power of 2 is 17 to the power of 4. And we can see it's 4 because it's 6 minus 2, because we had 6 17s at the top of the fraction, which cancelled with 2 that were at the bottom of the fraction. So the general rule is that x to the power of a divided by x to the power of b is x to the power of a minus b. Or in other words, when you're dividing two powers of the same thing, like 17 to the power of 6 and 17 to the power of 2, the rule is to subtract the powers. Dividing two powers of the same thing, subtract the powers. So I've done a little arrow there pointing out the fact that 17 to the power of 6 divided by 17 to the power of 2 is not 17 to the power of 3. You don't divide 6 by 2, you subtract the powers. And I've deliberately chosen numbers there where you could have divided them if you didn't remember the correct rule. So remember, dividing powers of the same thing, subtract the powers. Now here's another example showing a different rule. I've got 16 to the power of a half multiplied by 16 to the power of a half. Now, from our previous rule about multiplying powers of the same thing, that should be 16 to the power of 1, because a half plus a half makes 1. So 16 to the power of a half times 16 to the power of a half makes 16 to the power of 1. And of course that just means 16 on its own. So 16 to the power of a half times 16 to the power of a half is 16. But we know that by definition, the square root of 16 multiplied by the square root of 16 gives you 16, because that's what a square root is. The definition of a square root is a number that when you multiply it by itself gives you the number of which it's the square root. So in other words, 16 to the half times 16 to the half gives you the same result as square root of 16 times square root of 16. So that is to say that square root and power of a half mean the same thing. X to the power of a half for any number means the same as the square root of x. And that's a rule that you can extend to further roots and fractional powers. So x to the power of a third means the same as the cube root of something. So for example, if you see 4096 to the power of a third, it means the same as the cube root of 4096. And the cube root of 4096 is 16, because that's the number that you need to multiply it by itself and by itself again to get 4096. So 16 times 16 times 16 again is 4096. So the cube root of 4096 is 16. Okay, here's a reminder of powers of 10. So 10 to the power of 4, that's 10 times 10 times 10 times 10, which is 10,000. Continuing a pattern, 10 to the power of 3, which I haven't written, but is 10 times 10 times 10, gives you 1,000. And 10 squared is 10 times 10, which is 100. And so we've got a pattern here. 10 to the power of 4, 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and then continuing that, 10 to the power of 0, 10 to the power of minus 1, 10 to the power of minus 2. And looking at what they're equal to, so it goes 10,000, 1,000, 110, and you're clearly dividing by 10 each time to get from one line to the next. And for that to continue, the next one has to be 1, the next one has to be 0.1, and the next one has to be 0.01. And that gives us a few rules. So first of all, 10 to the power of 0 equals 1. Could have started with some other number than 10, and we would have got anything to the power of 0 equals 1. So there's a general rule there that anything to the power of 0 equals 1. That should just be revision from an MYP2 unit. But then when we go further, 10 to the power of minus 1 is 0.1. 10 to the power of minus 2 is 0.01. And in fact, that's the same as 1 over 100, or 1 over 10 squared. Now, it's quite a common mistake to think that a minus power should be a minus number. But in fact, a minus power just means 1 over the corresponding positive power, so it's a very small number. So just summarizing a few of the rules from that, and patterns to spot. So big important pattern that's going to be useful in the next chapter is that the index number gives the number of zeros in a power of 10. So for example, if you've got 10 to the power of 4, it works out to be 10,000, and 10,000 is a number with a 1 and 4 zeros. So power of 4, 4 zeros. That also works with minus powers. So 10 to the minus 4 has also got 4 zeros in it. They're the other side of the 1, and you need to include the one that's before the decimal. But if you include the one before the decimal, 10 to the power of minus 4 has 4 zeros in it. So with a power of 10, the exponent or index number or power always tells us how many zeros there are going to be in it. And that's going to be a useful thing in the next topic. Another thing we just need to be aware of then, zooming in, anything to the power of 0 is 1. So I talked about that previously. So for example, 17 to the power of 0 is 1. I did it with tens there, but I could have started with any number and it would have come down to 17 to the power of 0 or 10 to the power of 0 or any number to the power of 0 being 1. So that's a general rule. Anything to the power of 0 is 1, with the exception of 0 to the power of 0, which isn't defined. That's a whole other mathematical kettle of fish, which we don't need to talk about in this unit. And then finally, a negative power means 1 over the corresponding positive power. So for example, if you saw 17 to the power of -3, that would mean the same as 1 over 17 to the power of 3. Negative power means 1 over the corresponding positive power.